Good day. We're going to continue the training on the training module on clean air regulation, which iterates the design system designer and testing providers perspective. This is going to be the second part of the initial video which we did beginning of the week. Now let's look at the regulation. We stopped at regulation 8, regulation 8, first module. So what we're going to cover today is for the next 5 to 10 minutes, what we're going to cover is on the performance monitoring of air pollution control system, maintenance record, and change in occupancy. There's going to be only 3 segments here because this would take the performance monitoring and maintenance record. It's a very wide area to cover, and we will try to take the second module in a much shorter duration so that it's not going to be too impact. Okay, regulation 9. What does regulation 9 says? It says performance monitoring of air pollution control system. Now, the premises or the system provider or basically the end user, okay, pihak pengilang, or anyone who's going to get the who's considered as the owner in the form when we do the notification. Equip the premises with relevant facilities, equipment, or instrument to conduct performance monitoring of the air pollution control system. Okay, daripada pendapat kami lah. So this is one area which is very lacking. Jabatan Alam Sekitar mereka sendiri were aware of this biggest setback. So that is where kalau kita tengok sekarang kita ada competent person training dekat EMAS for dust collectors, for scrubbers, for wastewater treatment and all that. Mainly because DOE is preparing a platform to make users understand, not to apa kata 100% bergantung system providers. They don't want that to happen. They want basically the operator is competent enough to run. You see, that's the most important thing. So now this is also important for the person who's involved as a competent person, kan, melibatkan diri apabila sesuatu project is taking place now at the initial state itself. So that means now usually when you look at the ventilation system, okay, usually end user, okay, for instance, let's say there is a solvent plant or there is a mixing plant, he's going to say that, okay, I'm going to have a lot of airborne hazard. Saya akan mempunyai banyak apa kata bahan mendasing yang mudah terapung, which is occupational hazard. So now they will call a system provider. So the system provider will work on it, work on the design. They'll get the permitting done, regulation 5 buat notifikasi, and proceed with the whole thing. But one area which gets overlooked is the actual, how are we going to gauge the performance? I think kita pernah tengok this particular chart, okay. So from my point of view, we see after serving the industry for several years, apa kita nampak the major problem there is actually this. The wholesome picture tak ada. People always tend to think that, okay, when I install a system, okay, what I need to do, I need to get the notification done. Kita minta DOE punya kelulusan, kita minta DOE punya apa kata green light untuk pasang. Okay, kita dah comply. So bila auditor datang, kita tengok you ada approval, ada buat notification, done and all that. And then right after that, okay, setahun sekali kita buat monitoring. We will cover in the subsequent module later, on the monitoring limits, frequency and all that. Okay, ada cukup. But this particular model, this particular need is not covered because this is also partially, I think, due to lack of how to say importance being given by system installers themselves. You see, system installers is very focused in installing and getting the permit. But you see, the permit or the approval which DOE gives or the notification yang validation yang dia buat on behalf is just the beginning. Assuming that, okay, Regulation 7, Regulation 5 kata, okay, you give me a reliable design document. DOE akan semak semua. Dia akan bagi tahu, okay, thank you, okay, it's all okay, you boleh pasang. Then after you pasang, what do you will do? After you pasang, you'll submit declaration. But most of the time we think it stops there. No, it doesn't stop there. It actually begins here. Kalau kita tengok kat sini, peak, it actually begins here. You see? So that means, in fact, the when you complete Regulation 7, DOE actually will give you an acknowledgement letter. Dalam acknowledgement letter tu dia dah bagi terms and conditions, terma dan syarat. You have to follow this regulation, this regulation, this regulation. So what exactly they're saying is, now you have told me that your system would be able to perform at this peak. Or let's say kalau you buat commissioning data, you will get this peak. So your system must always work on this peak, and it should not. It always must be above the acceptable level. It must always be above the acceptable level. Kalau kita tengok this particular chart, it always has to be here. This is what we need to do. But how do you ensure your your process is actually within that particular range? How do you ensure? So this is where you have a lot of other elements. For instance, macam, okay, I'll give you one example here. Okay, kalau kita tengok regulation 9, dia kata you have to have certain instruments or whatsoever. Okay, let's say we will take a simple system, a lab hood. Okay, a lab hood. Now, when a lab hood is being designed, we're going to have specific flow rate, specific amount of air is going to go inside here. Let's say 2000 CFM. Okay, 2000 CFM is going to go inside here. Now, how do we ensure? Okay, when we tested, okay lah, kita dapat lah 2000 CFM. How are we going to ensure this 2000 CFM is continuously? I mean, it's running at 2000 CFM every day or every week or every month. So simplest form of instrument is to put a gauge. Kita letak satu gauge kat sini, static pressure gauge. Okay, a static pressure gauge is much accurate, much reliable and easy, because every day, okay, let's say for the 2000 CFM, the static pressure will show, let's say, about 1 inch water gauge. Okay, so we know whenever it drops above 10%, above 10% variance, let's say dia jatuh kepada 0.9. Okay, what we need to do, we have to cross check back again whether the flow rate is okay, because 2000 is equivalent to 2000 CFM is equivalent to how much velocity is going at the opening, how much velocity is going at the ducting, how much velocity is coming out at the chimney too. You see, because kita ambil model conservation of energy. Okay, in a typical dust collector, in a typical ventilation system, okay, whatever flow rate which goes in is the flow rate which is going to come out. Conservation of energy, yeah, conservation of energy. So taking that into consideration, whenever there is a drop in flow rate, there's going to be a drop everywhere. You're going to have a drop at the suction point. That means the suction is not going to be strong. That means you're not going to remove vapor to 100%. Bila dalam ducting tu jatuh, ini bermaksud condensation may take place. Bila flow rate jatuh, scrubber velocity or what do you call filtration velocity, it's going to drop. What's going to happen to the fan? Okay, the fan is basically going to produce less air because it's shown that indication. Or maybe the fan has to work extra harder. Okay, that's another thing. Chimney, definitely you're going to have a drop in velocity. Bila drop in velocity berlaku, what will happen? You're not going to have momentum. You're not going to have momentum to push the emission to create buoyancy. Why 8 meters per second or 12 meters per second of efflux velocity is iterated? Why is it so important? Why is it so important? Because you see, the reason why we have that, we need the momentum. The momentum will create buoyancy. This buoyancy will produce plume ride. Buoyancy ini maksudnya momentum ini akan memberikan kemampuan untuk udara tu menjadi lebih ringan, dan juga dia akan disperse effectively. When this dispersion happen, the entire elevation akan maintain dekat atas. So dia tak akan jatuh ke paras bumi. It's not going to, ground level concentration will always be zero. That's the reason. So going back to this, going back to what you said, okay, basically the regulation ni apa dia kata, have proper facilities. Okay, so for a typical for a typical LEV system without any air cleaning device, or even with just filter, activated cover filter dan sebagainya, the easiest way is to always indicate the static pressure. Kalau tak ada static pressure, then you take the flow rate by using proper instruments, you see. But problem with flow rate is it's very dynamic. So static and also labor intensive. So the best way is to always use gauge. Sama juga macam dust collector. Kalau you ada dust collector, now DOE has their guideline. Okay, we'll cover a separate module on this, but they have their guideline for a dust collector. What you need to know, you have to know the differential pressure berapa, temperature, what is the temperature going in, what is the flow rate going in. You see, so in order to maintain all that. Similarly to scrubber, what is your liquid flow rate? You see, what is your air flow rate? Okay, what is the individual static pressure losses? Kita nak tengok dekat dia punya scrubber body, kita nak tengok dekat dia punya packing, kita nak tengok dekat dia punya demister pad. So all this, why it says we need this? Because not for any particular reason, not for compliance is again macam kita cover the module 1. It's not something just to adhere. The compliance is actually a form of guidance untuk kita ikut supaya we can basically know. So kita track when we log every day, okay, every day, week and all that. So this is what going to happen. Kita akan tahu dia punya pattern kemerosotan, the degradation pattern. And we know when the pattern goes below this level, when the pattern goes this level, that means system itu kemerosotan system itu will have an impact both ways in terms of suction or in terms of occupational hazard and also environmental hazard. You see, so this is the reason why preventive maintenance itu penting. Preventive maintenance is just not changing things and all that. And preventive maintenance is also the effort yang kita ambil untuk buat semua testing. You see, semua testing ni. So that bila benda ni jatuh, kita buat corrective action and bring back the performance to the peak. Seperti mana yang, but in order to do that, okay, what we need proper instruments, okay. Conduct performance monitoring of the components of air pollution control system as determined by director general. Okay, there are certain type of instrument macam dust collector, scrubber, you have to do performance monitoring by a professional engineer every 5 years what's not biasanya dia akan nyatakan dalam you punya approval letter. So kalau tak, based on the DOE guideline themselves, dia dah beritahu daily apa you kena buat, weekly apa you kena buat, monthly apa you kena buat, annually apa you kena buat. So you must complete this, but not just for the sake of completing, but to understand that it is a form of performance monitoring. It's a form of performance monitoring. It is actually this particular model. Yeah, this particular model. Now let's look at the next one. Maintenance record. An owner or occupier of a premises shall maintain records on manufacturing process, maintenance, performance monitoring, air pollution control system. The record shall be kept. Okay, what exactly this is? This is stage of management. This is basically bookkeeping. You see, when you have a design document, you must have. This is not merely for any reasons. Yeah, this is also to show that you have a good practice to manage your system. Okay, when you have an issue with the system, how are you going to troubleshoot? How do you troubleshoot a ventilation system? You see, now let's say ada orang baru masuk, a person, new competent person masuk, and then dia dapat emission report, or dia dapat detail permission, detail performance report yang mengatakan yang menunjukkan bahawa there is a degradation. So what do you do? First thing kita ambil design document. From the design document kita tengok what was the flow rate design, what is the hood flow rate, what is the duct flow rate, what is the scrubber flow rate, what is the scrubber details, what is the scrubber liquid loading, liquid flow rate berapa, gas flow rate berapa, packing height apa. You see, the same goes to dust collector, how many numbers of filters, what are the specific requirements of all the design kita ambil, and then kita compare dengan actual. Then kita akan tengok ada displacement, ada kemerosotan berlaku. So kita cari punca dia, kat mana benda tu jadi. So that's the whole thing. But how are we going to do all this if you don't have the design document, if you don't have the commissioning data, you don't have the baseline data, you don't have a trend of periodic data, you're not going to be able to troubleshoot. So sometimes you get a situation di mana sistem tu dia kurang daripada 8 meter per second, for example, for efflux velocity, or system tu mempunyai high amount of certain emission quality. You will not be able to troubleshoot the system unless you know apakah kemampuan sebenar sistem tersebut. So in order to do that, you need all this. So whenever you want to pass over, is that someone is buying over a system or whatever, you should transfer this whole thing so that a good operate. I mean, a good operation and preventive maintenance protocol would be apa kata handed over. That's the whole reason. So the last part will be change in occupancy. Okay, when you have change in occupancy, where a person becomes the occupier of any premises, okay, the condition restriction, okay, we have to transfer the whole thing to them. Okay, transfer the whole thing to them accordingly. So before transfer, the most important thing kat sini is we must have the complete detail. Yeah. So to recap balik, we will look at these three things. Kita tengok performance monitoring. Performance monitoring is very, very important so that we can maintain this, so that the system will run within this condition at all time. Why this is important? Sebab one day or one session of emission, and let's say kalau emission dia terlampau tinggi and downwash berlaku, this whole what will happen is high concentration emission is going to go down and probably akan affect sensitive recipient. Then pencemaran akan berlaku. People going to get affected, and then they akan basically it's going to create a big impact lah. So that is why performance is important. But another important thing that regulation 9 which clearly says is that pastikan you have proper tolok tekanan, the proper instruments. You see, so that means when there's a designer or system provider memasak suatu system, you ask them, hey, how are we going to maintain all this? What are the procedures? What instrument you bagi? What is the training you're going to give me so that I will be able to run that? So all those must be cross-checked, yeah. So the young regulation and clearly states that, okay. And then maintenance record. So you have to keep the maintenance. Why you keep the maintenance record? Macam saya jelaskan tadi, troubleshooting. Must have the design, must have the baseline, must have what is the maintenance record. I mean, when you change the filter. So for instance, you think, prior to the maintenance, you dapat 2000 flow rate. After what, then somehow or other there was a drop. There was a drop in performance. You tukar filter dia. Bila you tukar filter, performance tu tak naik pada 2000. Dia sangkut kat 1000 saja. So you keep wondering why is it happening. After that you realize filter spec yang you guna is has higher static pressure loss. The previous filter was a wrong selection. So why that happened? Because there's no proper record in terms of what is the right model, with what is the right type, what is the right pressure loss, and all that. This is what happens. So that is the reason why we must keep the record accordingly. Yeah, and also to transfer it to new owners or whatsoever when change in occupancy takes place. All right. So that is all for this time. All right. Do not hesitate to contact us for further questions. We shall meet again in the next module. Good day. Bye bye.